Okay folks, so a question that we have here today is once again based off the surface geometry, and it's another transition piece. You can see we were given the elevation here, plan here, pictorial view down here, little graphic of a little robot that it's kind of based off, and a little bit of information on the question. So I'm just going to read out the information on the question and we'll get started then. So it says, a student is planning to create a model robot based on a design similar to the one above shown, or shown above. The main body of the robot is created from a single sheet metal piece, so one flat sheet piece of metal, as shown in the line diagram to the right, so we can see obviously over here. And the plan and elevation of the main body are given, complete a one-piece surface development of the surface. So in this case we actually have to develop out the whole surface of it. Now you can see it's a little bit irregular shaped. If we just base it up here, we can see the elevation up here, the plan here. We can see the elevation up here is made up of a semicircle that is extended on with two lines, and it's the exact same in the bottom part. So the top part, small semicircle, the big part which is sitting on the ground is another semicircle. And what we're going to have to do with that is, anytime we have curves, we're going to break it up with 30-60 degrees, and then we are going to basically use the triangulation method to kind of figure it out and do the surface development, where we're going to get various true lengths and we're going to have to get the true shapes of those various triangles inside it. So what I'm going to do now is I'm going to kind of flash to the elevation and the plan so that you can see me doing that in a little bit more detail. Alright, so at this point you can see just in a little bit more information here, we've got the elevation up here, the plan down here, and as I said, when we have circles, generally what we're going to do is divide them up. And you can see here we actually have two semicircles. So we have the semicircle up here on the top surface, which is up here, around this section here, and we've got the semicircle on the bottom surface. So when we have two semicircles, what we're going to do is we're actually going to split them up into 30-60. Okay, now I'm going to use pencil here because it's a little bit lighter, and then I'll go over it in pen so it stands out a bit clearer. So just from the center there, 30 that way. Split it up, 30-60. Now, as you can see there, I have split it up into 30-60 degrees, and what I would do at this point is use labels. So if I'm going to label my plan, the top surface here I'm actually going to use letters, and on the bottom I'm going to use numbers. So this point here, right here, I'm going to call A, and so on, B, C, and D, and for the sake of it I'm going to label this one E as well. And then this one here I'm going to use numbers 1, 2, 3, 4, and then this one will be 5. Okay, now you might ask, why didn't I label this around the other side? Well, when we're developing it out, a lot of this is actually symmetrical, so if I do all the labels and I get the true lengths on one half, then essentially I have the true lengths for all on the other side as well. So I'm just starting it that way. Now, at this point, the reason I use pencil is because I want the other colours to stand out more. And what I'm actually going to do now is I'm going to start putting in various element lines basically. Okay, so if A was to join to 1, just like that, that would be an element line. Then B would also join to 2, C to 3, and so on. C to 3, and then D to 4. And obviously I've it done on one half, so it should happen obviously on the other half as well. Only this time I obviously didn't use letters or numbers, but we know what they're joining to because it's basically the exact same image on the opposite side. Okay, now you can see I kind of have it all split up there. I've got this section here, 2, 3, 4, 5, 6, 7, 8. And essentially if we were able to develop out those 8 surfaces and join them all together and get the true shape of every one of them, then we have our development. But it's a case now then we actually have to work out the various true lengths. Okay, so to be able to work out the various true lengths, that's actually not too difficult. But the problem is, we know, okay, if we think of triangulation or a rectangle, let's say if I was to start at this point line here, right in the middle, that is going to be a good starting point when we're actually completing the development. So A1, well first of all, if I have it labelled in plan, I should also label it in elevation. So there's my A, will be directly above it, and my 1 will be directly up here. So let's label the rest of it, and we'll get onto the true lengths then in a second. So to locate B and so on, now I'm going to project these up. Okay, if I haven't joined in elevation or in plan, join them in elevation. So D joins to 4, as you can see there. D joins to 4, 3 joins to C, 2 joins to B. And there we go. And it would obviously be the exact same on the opposite side, but obviously when we're looking in this direction we can only see all the way around A to 1. We don't actually see this one right here. Okay, because it's at the back. Now, at this point, if I was to say, remember if we go back to when I was saying A to 1, well, first of all, one true length we can actually identify straight away is this A to 1, because A to 1 is parallel with one of our principal planes. We can see there the line here is parallel with the XY line. That means then in elevation A to 1 is actually a true length. So that's the first true length we've figured out. Now, from B to 2, that cannot be a true length in the plan or in the elevation, because in the plan it is not parallel with the XY line, and in elevation it's not parallel with the XY line. The same with C to 3, D to 4 and E to 5. So we're going to have to work out them true lengths as well. Now, all of these lines here, we're going to call them elements. Okay, these red lines here. This one, this one, this one, all the way around A to 1, B to 2, C to 3, D to 4. They're all elements. Now, if I start with A to 1 as a true length, and I was to, let's say, start it out here. Now, A to B is also a true length, because I would just take that distance on my compass and mark it off. Obviously, we can't measure with a set square the distance, the circumference, but what we do is we just take the closest accurate distance we can with the compass. So A to B, we would take that as a true length, and I could also take 1 to 2 as a true length, because both of them, 1 to 2, as we can see, it's on the ground, so I can take that as a true length. And A to B, if you look up here, that's on this line, which is parallel with the XY line, so I can take that one as well. So I can work out this A to B, I can work out A to 1, and I can work out 1 to 2. The problem is, I don't know when I swing an arc in a minute exactly where 2 is going to be on that arc and where B is going to be. Okay, so what we're going to use is the triangulation method, and we've done the element lines. Now what we're actually going to put in is the diagonal lines to be able to complete the triangulation method. And to do the diagonal lines, this is what I would do. So from 1, I'm going to join 1 to B, and then I would also join B to 3, 3 to D, and then D to 5. And what you can actually see if you look at it here now, in this section A, B, 2, 1, I've it now split into triangles. You can see I've it A, B, 1, and I've got 1, 2, B. And if I was to work out the true length of 1 to B, or B to 1, however you want to call it, then in that case I would be able to locate exactly where point B is. And the reason for that is because once I work out that length, I can mark it off of 1 and I would find the exact position of it here on the arc. So that's how that works out. Now, if I did the triangulation method here, think of it as symmetry, and it was just like this and it was flipped over. So 1 would join to here, and so on. So when we have it worked out for one side, we technically have it worked out for the opposite side as well. And then this one would mirror this one. As you can see, that line there is a mirror image of that one, just been flipped over. Okay. Once again, if I have it done in plan, I should also do it in elevation. So you can see 5 joins to D up here. This is why I wanted to use colours. D will join to 3. 3 will join up to B, and B will join down to 1. There we go. Okay, you can see kind of how it's broken up there at this point. Now, what I'm actually just going to do before I work out the true lengths is I'm just going to flash down here to a second to the pictorial view of it. Now as you can see at this point in the pictorial view, I have already put in all of my various elements, okay? So I did A to 1, B to 2, C to 3, D to 4, and then E to 5. Now it's a case of, and this is literally just to kind of bring it into a 3D kind of perspective and showing you where the diagonal lines were joining to. So if you can remember, and if you look back at your sheet from wherever you were, 1 joined up to B, which was a diagonal line, and what we're going to do is basically get the true length of that blue diagonal line there from 1 to B to be able to determine the exact positioning of B. And now I would also do the exact same then from B to 3, then 3 to D, and then obviously D down to 5. And that there is known as the triangulation method. And the reason they obviously call it, I'll just put in that one heavy there now. Sorry. The reason they obviously call it is the triangulation method is because you can see obviously in each of these surfaces, these sections, so as I said A1, 2 to B, that section there, we have it now split into 2 triangles. And what we're essentially doing is we're drawing this development of the surface just by drawing a series of triangles all connected to one another. So this section here, let's say we were to start off with that, I would start off by doing that one there. I'll actually use a different colour here. I should have used maybe a different colour. So if I just use that, that's the first triangle, let's say, we would draw. Okay, and after drawing that, we would then fill in the next triangle. And now I'll use just a different colour. I'll actually go back to the blue. We would start off with this one. And we would just continue in that sequence. So you can see here, we have 2 of them done. Then the next one, just to show you again, I'll just do this one in green so it stands out again. It would literally just keep going in that sequence, and all I'm doing is, because I've worked out the various true lengths that I need, I'm just basically building it the whole way around. And as I do it on one side, I should also do it on the opposite side. Okay, I hope that helps there now. So what I'm going to do now is I'm just going to flash back to the orthograph. So at this point what we're going to do now is we are going to work out our various true lengths for our red lines, which, as I said, were called our elements, and then our blue lines, which are our diagonals. So on this side here I'm going to do elements and diagonals, and I'll have 1 or 2 to work out here as well. So just starting off there, I'm going to use the cones principle to start it off. So just coming up from roughly, I'll just pick a line roughly about here. Okay, and I'm going to imagine A, B, C, D and E are all in one position right here. Right here at this point here is my, as I said, A, B, C, D and E. Every one of those, I'm just imagining them as a cone for now, for a second, okay? And every one of them is the apex of a cone. And we know in plan view, when you look down on top of the apex of a cone, the apex is always directly above the center. So, with that in mind, if I was working out, and as I said, I'm working out all the elements first, which is the red lines, which are all these ones, which are the true lengths. I already have A to 1 worked out, so technically I don't need A again here. But the first one I will work out is B to 2, which would be the same as this guy here as well. I haven't him labelled, but it's going to be the exact same. And to be able to work that, the true length of it out, okay, I'll just extend out that line a little bit there. What I know is, if B was the apex of a cone and I was looking down on top of it, and the apex is directly above the centre, well then B to 2 is my radius, if I was to draw the cone looking down on top of it, because that's what we would see as a circle. So I take that radius, and directly underneath B, which is where the centre would be, I'm going to step that radius out. And right there is my B to 2. Okay, so I'll put that one in red because it was red on the sheet as well. So that is the true length from B to 2. I'll just write that in. B to 2. Okay, the exact same then for C to 3, and so on. So you can see the sequence the way it's going. C to 3. And as I said, I'm using the exact same positioning because I'm putting C here now. C is the apex now. Directly below it, right here. At that point there, right here, is going to be C to 3. And that is my true length from C to 3. And you can see how it's going from here. So at this point now, I just have to work out D to 4. So I'll fast forward there. Okay, as you can see, now we have all the true lengths for every element there. A to 1, which as I said we already previously had, and we've worked out B to 2, C to 3, D to 4, and one I actually just left out as well was E to 5. Okay, now another way just to show you very quickly of how you could actually work out E to 5 would have been just to do it like this as well. So if I took E over here as the apex of a cone, and E to 5 obviously down here is my radius. So if I was to take that as the radius, which I've already done and it's already set on my compass, I could have rotated it out like that, and at the extreme generator point, because the extreme generator we would see is parallel with the xy line, at this point here I could transfer it up where it crosses the xy line. At this point would have also been the true length. Now that is just showing you the other method for getting the true lengths. Now sometimes it's just easier to put all the apexes in one position rather than working them all out from an A1 here, a B here and so on. But that's just showing you the other way of doing it. So that's the true length also from E to 5. So I will actually just put that in now. And it will be E to 5. Okay. We're going to revert back to this method now, because this time I'm going to work out all the diagonals. So B to 1, B to 3, 3 to D and D to 5. And then if we have them on this side, we have them on the opposite side. So once again, this time I'm going to use a blue. So I'll extend over my line here at the top. And this time I'm going to use a blue. Okay, now at that point that is the apex of a cone. And if we take, obviously B is the apex and 1 is on the ground, that's my radius. So B is the apex, 1 is on the ground, that's my radius. I'm going to take that and from here, step it out. Forgot to extend out my line. There we go. And at that point there, we now have the true length from B to 1. And at this point, that is the true length from B to 1. Just like that. And we're going to do the exact same now from B to 3. And so on. So take that distance on your compass. And then from here, step it out. There you go, that one is B to 3, and I'm going to fast forward now because at this point the last two I have to work out is D to 3 and D to 5. Okay, as you can see now we have all the elements true lengths worked out, which are all of these guys here, and we have all the diagonals, and I just put them in blue to correspond with the page, and obviously the elements are in red to correspond with the page as well. All the true lengths have been worked out. We actually have every true length we need, so now we can actually start the surface development. So what I'm going to do now is I'm going to pan out because I have more space at the bottom of the page to be able to complete the surface development. Okay, right folks. Now that we have all the elements true lengths worked out, the diagonal true lengths worked out, and we have the various true lengths that we need from the plan view here on the arcs, we'll start completing the surface development. So a good place to actually start is this A to 1 here. Now this isn't the true length in plan. As I said, it is parallel with the xy line, so in elevation that's actually our true length from A to 1 here. So I've that already stepped out on my page, as you can see. So I picked a point, as you can see, roughly down in a little bit of space where I'm going to be able to complete the surface development here. Picked a point here, A, took this distance from A to 1, marked it off there as my 1. Now, what I have to do at this point is take the true length from A to B. And if I take that true length from A to B, which is right there, I'm going to step that out either side. Because remember, if we do it on one side, it's obviously we're starting in the middle, so it's the exact same at the opposite side. And then it's going to be the same distance from 1 to 2 as well on the opposite side. So take that distance. There's my 1. Go along there. So somewhere along here is the 1, sorry, there's the 1, somewhere out along there is the 2, somewhere up here is this point up here. Okay, now I need to find the exact positioning of one of those points. And to be able to do that, I'm going to actually use one of my diagonals through lengths that I found up here. And as we can see, we already have A to 1. So I have 1, and the diagonal I did was from 1 to B. So from 1 up to this arc here, somewhere where this true length is going to cut in this arc is going to identify the exact positioning of B for me. So what I do is I take the true length from B to 1, or 1 to B, whichever one it was, and you can see I have them clearly labelled. So make sure you label yourself as well, it's very important so you don't get lost. And take that distance there, and at 1, mark it off, and do the exact same at the opposite side. And there is 2 more points. Now on this one, it's called B, and on this one we didn't give it a point, so I'm just going to mark it there. And at this point now, I can actually find where 2 is. And the reason I can find the exact positioning of 2 is because I have now located my positioning of B. I can take the true length from B to 2, which was this guy over here. And with that true length, take it here, mark it off, and do the exact same at the opposite side. And mark it off. And once again, that there is my 2. And this here is just a point. I haven't given it an actual label. Okay, we just keep going in that sequence. Okay, so one sec, I'll actually just put in the diagonal line, which was in blue. Just for reference purposes. And then we had another diagonal line here. And then our element lines was from B to 2. And you can actually start to see the triangles taking shape. 1, 2, 3, 4. So this one, this one, this one, and this one done. So I could actually tick them off as I was going. So I've done that one, done that one, done that one, and done that one. And we keep going in that sequence. I'll do one more sequence and then I'm going to fast forward it. Okay, so I'm going to once again take the true length from B to C on my compass, which would be the same as that distance there. And at B, mark it off. And the same from this point over here, mark it off. And the same thing from 2 to 3, that distance, not 2, somewhere along that arc there, and somewhere along that arc there on the opposite side. So somewhere along this is going to be 3 in the point over here as well. And now let's work it out. This time it's I have the B located, and it's the diagonal from B to 3 is going to help me locate my point down here. So come up here, find it, it's this one. There you go. And on B, mark it. And there we go, I have located my tree. And I do the exact same at the opposite side. That has located my point for me, which is technically, just mark it off, it's actually this point up here. Okay, now what I have to work out is, I've worked out 3. Now I just need the true length from 3 to C, or C to 3, however I indexed it. And we can see that we had that one up here. So just take that, working out roughly the same. And at 3, I'm going to mark it off there and do the exact same to the opposite side. So you're just following the same thing, copying it over. So there now is my C, there's my 3, there's a point there. Okay, put in my element line once again. And there is my other element line on the opposite side. And now I'll put in my diagonal lines. And the diagonal line is going this way, yeah. B to 3. And this point to this point. There we go. And as you can see, I can tick off another triangle on this side, and on this side, here, and also here. And you can see I've got 1, 2, 3, 4, so then essentially 8 to do altogether. Okay, so what I'm actually going to do at this point is I'm going to speed up the process. Okay. Okay, at this point now we can clearly see that we have all found all the true lengths of all the element lines and the true lengths of all the diagonal lines in between. Now you did not have to actually technically put in all of these diagonal lines, I just put them in for understanding purposes. Now what I'm actually going to do is I am going to sketch the final solution and heavy it in. So I'll speed that up there now. Right, there we go guys, that is the complete surface development of the structure given to us of the sheet metal piece that was meant for a robot. Tricky enough question in that there was quite a lot of working out in it and a lot of location of the true lengths and then just using the triangulation method. Now you can see how it was split up here and using the letters. You could get very messy in how you label it with letters going all the way up here. If you can actually see the symmetry in it and work out one half of it, then it's easy to work out the other side and just keeping it. Okay, very good question and very informative once again on the various true lengths using the triangulation method. Hope you found that helpful. That's another one there complete guys.